Welcome to our channel, Code Crusaders. Let's get started and tackle the problem together. That is, non-negative integers without consecutive ones. Let's solve the problem of finding the number of integers between 1 and n, inclusive, that have binary representation without two consecutive ones. The approach used in this solution is a recursive one, where it starts with the value 1, which is the smallest number with binary representation without two consecutive ones, and performs a depth-first search, DFS, to traverse through all the possible integers. The function DFS, int currentNum, int lastBit, takes in two parameters. CurrentNum is the current integer value that we are checking. LastBit is the value of the last bit of the binary representation of CurrentNum. The function starts by checking if the current integer value is greater than upper limit, which is the value of n passed to the findIntegers function. If so, it stops traversing and returns. If not, it increments the variable count as the current value is a viable integer that satisfies the problem's condition. Then, it checks if the last bit of the current value is 0, if so it calls DFS, currentNum into 2 plus 1, 1. This is because if the last bit of the current value is 0, we can add a 1 to the end of the binary representation of the current value and still have a number that satisfies the problem's condition. Finally, it calls DFS, currentNum into 2, 0, to explore the next possible value by adding a 0 to the end of the binary representation of the current value. The findIntegers, int n, function initializes the variable upper limit with the value of n and then calls the DFS, 1, 1, function to start the traversal. The function returns the final value of count, which is the number of integers between 0 and n that have binary representation without two consecutive ones. Let's take an example, where n equals 1. Here, the integers from 0 to 1 that have binary representation without two consecutive ones are 0, 1, the function returns 2 as the final value of count. Let's take another example, where n equals 5. Here, the integers from 0 to 5 that have binary representation without two consecutive ones are 0, 1, 1 0, 1 1, 1 0 0. The function returns 5 as the final value of count. The time complexity of this solution is big O log n, as it performs a depth-first search and each value is visited once. The space complexity is big O log n as well, as the maximum depth of the recursion is big O log n. It's important to note that this solution is an optimized version of the brute force solution, which is to check all the integers from 0 to n and check their binary representation for consecutive ones and count them. Also, this solution is not suitable for large inputs as the time complexity is big O log n and the space complexity is big O log n, which could cause a stack overflow. Thanks for following along. I appreciate your attention, and I hope you found this explanation helpful. If you found this video helpful, make sure to hit the like button, leave a comment, and subscribe for more content like this.